Good morning. At least it's morning for me. I wonder what time it is for you. Hopefully you are having a lovely day, lovely week. And today we're going to start with 10.5b, which is more hyperbolas. So I'm just going to start you with some reminders about what those hyperbolas look like, and then we'll jump into what we're going to do with them. So let's just recap real quick. We said if we have x squared over a squared minus y squared over b squared equals 1, that would be the equation of a hyperbola. This is the one that opens left and right. So something like this. And then the other one is y squared over b squared minus x squared over a squared equals 1. And this is the one that opens up and down, which always feels a little backwards to me. I always feel like the one that has the x squared, like the first equation we do, should go the other way, but it goes this way. So there's that. Remember the equation for finding the foci is c squared equals a squared plus b squared. My daughter wants to know if I'm watching Blippi on the iPad right now. No, babe, it's not Blippi. I'm talking to my students. Okay. And then the equation for the asymptotes is always y equals plus or minus b. Wrote it underneath. It's a weird way to write it. Plus or minus b over a times x. Okay, now I have one more thing to tell you about that we didn't talk about before, and that's called the transverse axis. So you have a vertex here and a vertex here. You have a vertex here and a vertex here. The line between them, I'm really sorry, guys. Kids, it's a struggle. This line is called your transverse axis.
I'm gonna say hi.
Okay, say hello.
Who is that?
You won't be able to see them. I'm just recording a video for them. So the transverse axis is just, it's the distance between your vertices. And you'll see in this lesson how that transverse axis comes into play. We haven't had to use it yet, but in today's lesson we will. Okay, so let's do the first example. For this one, for today, before it was they gave us an equation and we would graph it and find all the different pieces. Today we're going to be coming up with the equation. So write the equation of the hyperbola. And then they're going to give you some information. So the information they're going to give you is a foci of 0 plus or minus 5 and vertices of 0 plus or minus 2. Okay. So if we start by graphing this, so here's your axes. Foci at 0 plus or minus 5. So think about plus or minus 5 on your y, right? So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So this is your foci. Okay, and then it tells us that our vertices are at 0 plus or minus 2. So 2 and negative 2. Now, this tells you what your graph looks like. So if you think about your foci has to be inside the bulb part. It's going to go something like this. The arc of it right now is not a huge concern, just what direction it's going is what we're looking for. So we get this, okay? Well, we know from up here, right, when we open up and down, it's this equation, y squared over b squared. So we know we're going to be doing y squared over something minus, remember hyperbolas are subtraction, x squared over something equals 1. And now our job is figure out what those somethings are. So what is our b squared? What is our a squared? So if we look at this, we know right now one of them, we know this one, because our y here is 2, then our b squared, which would normally go right here, right, is going to be 2 squared. So we know that this is 4, okay? We need to figure out what is our a squared. And to do that, remember, whenever we have foci involved, we're using this formula. Okay, so we got to figure out what our C is. And C is the distance from the focus to the origin. So in this case, our distance there, our C, is 5. So we're going to say 5 squared, let's just write it as 25. 5 squared, 25, equals, we don't know our a squared, but we do know our b squared. Our b squared is 4. So if we take away 4, then we get 21 for our b squared. And we don't need to square root that, remember, because we're looking for b squared. So this would be 21, and that would make this your answer. Okay. All right, example 2. You are given that your foci are plus or minus 4, 0, and your vertices are plus or minus 1, 0. Okay, so if we graph this, we have plus or minus 4, 1, 2, 3, 4, 1, 2, 3, 4. Notice these are on the x-axis now. So there's your foci. And then vertices at 1 and negative 1. So this one is going to look more like this, because we want the foci to be inside of our arc. Okay. So we have this set up. We're looking for the equation. So our equation, again, now that we're going our arcs this direction, recall we said when they're going this direction, then we're using this setup. So it's going to be our x first. So it's going to be x squared over something minus y squared over something equals 1. And so our a squared, what's going to go right here, is going to be our vertex, our a here, squared. So 1 squared is just 1. And then we need to figure out what our b squared is. So if you look here, your c value from focus to origin, here to here, is 4. So it's c squared equals a squared plus b squared. So it's going to be 4 squared, or 16, equals a squared, which is the 1, plus b squared. So if we take away 1, 15 is our b squared, and that's what we want to use up here. So our answer is x squared over 1 minus y squared over 15 equals 1. Example 3. All right, so we have vertices at plus or minus 3, 0. We have foci at plus or minus 6, 0. So let's graph this. So vertices at plus or minus 3. 1, 2, 3, 1, 2, 3. So here and here are our vertices. And then foci, 4, 5, 6, and 4, 5, 6, here and here. So our graph, in order to keep the foci in the arc, would have to be this way. Ask yourself the question right now, because you're not getting these formulas, guys, on the test at all. You have to know these. So really spend some time thinking through, like, how does this all lay out? But ask yourself the question right now, does my x squared come first or my y squared come first in the equation? When it's sitting this way, I'm trying to think of a fun way for you to remember how it is, but when it's sitting like this, this is when your x squared comes first. Think of it like this. If you have the x of your vertices, your x squared is going to be your first thing. If you have the y's, if your points are like here and here, then your y squared is going to come first. Maybe that's a good way to remember it. So this is going to be x squared over something minus y squared over something equals 1. So now if we figure out what our numbers are that we're working with here, we know right now our x squared, because we know the x of our vertex is 3. 3 squared is going to get us a 9 right here. We need to figure out our b squared. So the way we do that is we look at this distance, which is our c, and our c distance right now is 6, or you could do this one, the same thing, distance of 6. So we're going to say c squared equals a squared plus b squared. So it's going to be c squared, or 36, equals a squared, which is 9, plus b squared, which is what we're trying to solve for. So take away 9, and you get 27 for b squared. So that's going to go right here, 27, and this is your answer. Okay. All right, last one. This one's slightly different, probably a little more challenging. I like this one a lot. I think this one's a fun one. So this one says, here's where your transverse axis comes into play. Your transverse axis is vertical. And is 4 units in length. Okay, and then it says your central rectangle, remember that's the rectangle we would draw yesterday in our graph. We'll draw it again today right now. So the central rectangle is a 4 by 6. The question is, what is the equation? So we're going to write the equation of the hyperbola. Okay, so now let's think about that. Your central axis is vertical. If you go back to the pictures I drew at the beginning, okay, the central axis being vertical, that's this, right? This is our central axis, and it is vertical. So that means my shape is going to, my arcs are going to open up and down, not left and right. So let's go back here. Okay. It says it is 4 units long, that vertical. Now, be careful with that. You don't want to go 4 units up and 4 units down. We want the whole thing to be 4 units long. So that really means we're going up 2 and down 2 to make this length 4, right? Because it's always symmetric. So that's going to put a vertex here and a vertex here. Okay. So it's vertical, it's 4 units. So we did this part, vertical and 4 units. That means if these are vertices here, our graph is looking like this. Okay, that should give you one piece of information. When the graph opens up and down like this is when your y squared comes first. So we should know right now that it's y squared over something minus x squared over something equals 1. Okay, now it's our job to figure out what those somethings are. Well, it says that our central rectangle is a 4 by 6. So 4 is taken care of already, right? So the length of the sides here is 4. We want the length, the left to right, to be 6, but be careful with that. If it's got to be 6 units, then it's 1, 2, 3, and 1, 2, 3, right? So the rectangle is going to go, like this. I'm just going to draw it in solid so you can see it a little better right now. So if this is the case, now we're figuring out, okay, well, our vertices are at 2, so that's our A value. Our B value. So if this is 2, then my B value, which is right here, is B squared, or 2 squared, which is 4. And then this other length is 3. That's our A value. Remember, we go A units to the left and we go A units to the right. So 3 is our A value, which means 3 squared, or 9, is going to go here. And that would be your equation. Y squared over 4 minus x squared over 9 equals 1. Okay? So just remember symmetry here. If it tells you 4 by 6, you're actually going 2 in every direction and 3, or 2 up and down and 3 left and right for that one. And that is it.